Hey y'all, welcome to Wednesday's video lecture. You might notice that we skipped section 3. That's okay. I want to do it next week because it fits in a little bit better. So on your note sheet, move on to the section where it says mass to moles. So where you see this title. So skip percent composition for now. But find in your notes really quickly where it says mass to moles, and that's where we will be working today. If you need to pause the video to find that, you can go ahead and do that. And actually, let me just say right now, if you ever need to pause the video, you can certainly do that. Hopefully that will help as you're trying to take notes. No shame in pausing to get stuff written down. All right, so here we go. When we are converting mass to moles, there's a process that we need to go through. The importance of this is because, like I said yesterday, there are not balances that weigh in moles because the moles of every element are different. The mass of every element is different. So there is not a way to measure in moles. So what we have to do is convert that to mass, which is something that we have a balance for that can actually do that. In fact, you'll be doing some of this tomorrow in class. But we have to convert back and forth from mass to moles quite frequently. So this is the process for doing that. The first thing that you need to do anytime you're converting between grams and moles, mass to moles, the first thing, without even thinking about it, you need to do is determine the molar mass. Remember, we talked about molar mass on Tuesday. That comes from the periodic table. So you look on the periodic table, determine the molar mass. That is always your first step. You are going to use that molar mass as a conversion factor to convert between grams and moles. Just like if you were converting between hours and minutes, like if you wanted to know how many minutes were left in your school day and you wanted to calculate that, to convert between hours and minutes, you know that there are 60 minutes in 1 hour. And that's just something that you know when you learned how to tell time a long time ago. Or you know that there are 100 pennies in $1 or 4 quarters in $1. So you can say, oh, if I have $7 and I need to go to the laundromat, or I want to go, I can convert that $7 into quarters just by going 7 times 4. I have 28 quarters. So if I have $7, I have 28 quarters. And you can go the other way with that too, right? You have a handful of quarters, you count them up. Oh, I have 32 quarters. How much money do I have? Well, 32 divided by 4 is 8. So you know you have $8 if you just count your quarters. Those are conversion factors that we just can basically do in our head, right? But that molar mass from the periodic table is a conversion factor, same way, to convert between grams and moles. Right? And because this molar mass is the mass of 1 mole, right? 1 mole, the conversion factor looks like this. So we get number of grams in 1 mole, or 1 mole in the number of grams. Just like with the dollars and quarters. We'd have 4 quarters over $1, or $1 over 4 quarters, or 60 minutes over 1 hour, or 1 hour over 60 minutes, right? All of those are ratios, conversion factors, however you want to describe them, that allow you to convert between one thing and the other. I think in the worksheet that you're working on, they did one about chicken eggs and quail eggs, right? And it was 16 quail eggs is 1 chicken egg, if I'm remembering correctly. So that's another conversion factor that you can use. How many quail eggs in 1 chicken egg? 16. This one is a little bit different because there's not just one number for grams. There's a different amount of grams for each element. And remember, like before, that comes from the periodic table. So you look up on the periodic table the number that is at the bottom of the square underneath the symbol. That is how many grams are in 1 mole. So when we're doing this between grams and moles, converting, the next thing you need to do after you figure out the molar mass is you need to look at the units you have to determine if you need to multiply or divide. Right? Just like with our dollars. Remember when I said I had $7? How many quarters is that? I multiplied 7 times 4 to get 28. But when I had started with quarters and said, oh, I have 32 quarters, how many dollars is that? I had to divide. 32 divided by 4 is 8. So I know I have $8. So depending on where I am and what I need to do will determine whether I need to multiply or divide. So you have to look at the units and determine if you need to multiply or divide. So here's an example. We'll do this one together. It says, what is the mass of 0.045 moles of sodium chloride, NaCl? The first thing we need to do is find the molar mass of sodium chloride. Remember, that's our first step. So go look at the periodic table to figure out the molar mass of sodium hydroxide. And remember, or sodium chloride, sorry. So you need to find the molar mass of sodium. It's over on the left-hand side. It's somewhere around 23, I think. Find the molar mass of chlorine. It's over on the right-hand side. It's like 35.45. If you add those two things together, I switch to my pen here, you get that the molar mass is 58.44 or 45. Those of you that came to class yesterday know I'm just learning this pen. So 58.4, we'll do a 5. And this is grams per mole. By the end of the semester, I'm going to have this down. 58.45 grams per mole. I apologize for the messiness. Okay, but that's our first step. Then the next step is we have moles. Remember, the next step is to look at the units to determine if you need to multiply or divide. We have moles. We need to get to grams. So in order to get to grams, we are going to multiply. So we're going to multiply 0.045 times 58.45. That will get us to grams. So the moles will cancel out because numerator, denominator. But that is what we need to do, is to multiply. So we take our handy dandy little calculator here. I'm using my phone. But 0.045 times 58.45 gives us 2.63. 2.63 grams. If you remember back when we talked about significant figures, when you multiply, your answer has to have the same amount of significant figures past the decimal as the least. So this has 3 past the decimal, this has 2 past the decimal. So our answer needs to have 2 numbers past the decimal. And then we always want to put our units, grams. So the mass of 0.045 moles of sodium chloride is 2.63. So that was what it would be if we'd weigh it out. And we got that by multiplying these two numbers together. All right. Let's try a different example here. All right. I've kind of written on top of this one. Sorry about that. So we got, if a student measured 0.25 grams of sodium chloride in the lab, How many moles does the student have? So now this time, because we're going the other direction, we started with grams and we're going to moles, we are going to want to divide. Because last time we multiplied to start with moles and get to grams. This time we're starting with grams and going to moles, so we're going to divide. So we're basically going to take 0.25, I'll try to draw it, 0.25 grams divided by 58, I know I'm off the screen, sorry, 0.45 grams per mole equals. So to get from grams to moles, we want to divide. This number is the same because we've got the same chemical, sodium chloride. So let's see, when I do this, 0.25 divided by 58.45, excuse me, I get 0.004228. Now, what I would probably do is, well, what I know I would do is rewrite this in scientific notation so I could do significant figures. Because if I do significant figures and just leave it, that would be 0.00. Well, that's not helpful. Because he measured something, he has to have some amount of moles, even though it's super tiny. So I'm going to erase this answer and rewrite that in scientific notation, because that is the best way to do that. So in order to do that, I get 4.28. Now I have the correct numbers of places past the decimal, times 10 to the negative 3, because I moved that decimal place 3 places to the right. So 3 places to the right, moving the decimal point, excuse me, gives me that answer, 4.28 times 10 to the negative 3. So when I did this one, I divided to get from grams to moles. To get from moles to grams, though, you multiply. Okay. We will do some more practice on these tomorrow for sure. And I do want you to do some practice yourself tonight. Let me erase all this. Sorry about that. Okay. So these practice problems that are showing up here are in your notes. I'm going to have you do them for basically homework. So work on these on your own. Look back at my example. Remember, if you're converting from moles to grams, you multiply. So that's my hint for these 3. You'll multiply. And then there are 3 others in which you will divide. So try these 6 problems as practice problems. Remember, you need to find the molar mass first, and then either multiply or divide. And that molar mass comes straight from the periodic table. So as part of your homework for today, I want you to practice those and finish that other sheet. And I think what I'm going to do, let's stop right there for today. That's enough for one day. So ignore all this. We'll do it later. I want to get to some announcements at the end. Okay. All right. So for tomorrow, if you're coming to class, calculator, goggles, make sure you bring them. If you are staying remote, tomorrow I will be sending you a Zoom link so you can join us in class. I'm sorry. I'll send it probably today. I won't wait till tomorrow. But today, Wednesday, I will send you a Zoom link so you can join us in class on Thursday. Don't forget that relative mass worksheet is due at the end of today. Bring your answers to the practice problems. There are actually 6 of them. So not 4, 6. Make sure you bring those with you. And if you would, go to tinyurl Tabor 14, because today's the 14th, exit, to get today's exit ticket. So as soon as you're done with this video, go there to fill out the exit ticket for today. Let me know if you have any questions, and I will see you all either virtually or in person tomorrow.